I drew this picture in the first video of the section here. So let me just kind of point out here, so this 3, 1, 2, this is really x, y, and z. This is an example of Cartesian coordinates. And so if you can do Cartesian coordinates in 2 dimensions, x is 3, y is 1 here, everything works exactly the same way in going from 2 dimensions to 3 dimensions. This is x, this is y, this is z. And so these are Cartesian coordinates. These are also called rectangular coordinates. We will in the future in this class learn other coordinate systems. So right now this is rectangular coordinates. There are other three-dimensional, other three-dimensional coordinate systems. Just like in Calculus 2, you should have learned about polar coordinates. So usually in 2 dimensions we represent things x, y, but then sometimes we go r theta. This is Cartesian coordinates here in 3 dimensions. We'll learn about other 3D coordinate systems later. So let me draw, in these first couple of videos I'll be drawing lots of axes here. Let's just put some points here so we get some idea of what's going on. So here we're going to have the positive x-axis, positive y-axis, positive z-axis. And so some important points just to be able to locate here. So this right here is the point x is 2. And then if we're on the x-axis, both y and z are 0 there. If we're on the y-axis, both x and z are 0 there. And if we're on the z-axis, both x and y are 0 at that point. So it's important to kind of, these are some of the most important points that you'll need to graph. In terms of planes, so let me once again draw some axes here. So if you just take the x-axis and the y-axis and take this plane here, so right in here we look at it in this way. If we ignore everything where z is positive, ignore everything z is negative, this is the xy plane, or it's exactly when z is equal to 0. So when you think about this, sometimes we'll kind of want to think about, we'll have xy plane, z is equal to 0, but we can kind of transform this into the xy plane in 2 dimensions. So for example, this point here, this might be 3, 0, 0. This would get mapped to 3, 0 in the xy plane. So we have xy plane. We can also think about x, y, z. For example, the yz plane. So this would be, here's the y-axis, here's the x-axis, and set x equal to 0. So you have this kind of thing going on here. This would be the yz plane. Take a moment, maybe you want to draw for yourself what would the xz plane look like. So this would be when y is equal to 0. So x, y, and z. And so what is going on here for the xz plane? So this would be, we want the x-axis and the z-axis. And there we get the xz plane. Slicing it that way, no positive y, no negative y. We want the xz plane. Okay, so these are all important things for us to know and care about. Okay, and then we also, yeah, so these are the coordinate planes. X is equal to 0, y is equal to 0, and z is equal to 0. I just drew those out for you. So an important thing here, then, is the notion of octants. So throw back to previous stuff. We talked about quadrants before, x and y. So you should know, like, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. But the point here is that, like, the x and the y-axis divide two-dimensional plane into 4 quadrants. So there are 8 octants that correspond to taking different combinations of x positive or x negative, y positive, y negative, z positive, z negative. So what you might do here is that, okay, so we might take, so I should say there's no standard, for quadrants we know 1, 2, 3, 4. The first quadrant is, the first octant is the only one for which we have a actual name for, and that corresponds to x is positive, or I guess non-negative I'm doing here. X, y, and z are all non-negative. So positive x, positive y, positive z, something something like this here, in this first quadrant, it's all the space is, going off in this direction, this direction, this direction. This would be the first octant. I think I may say quadrant there. Everything as of late, I should be saying octant here. So this is the first octant. We can have other octants. X is positive, y is negative, z is positive, x is negative, y is negative, z is negative. Those give us other octants. The most important one here is the first octant.